distribution based algorithm is the algorithm where every data point is considered to be a part of cluster and how likely they are meant to go with the cluster center. So every data point undergoes a predefined set of statistical distribution. So this is how distribution-based algorithm works. It creates data points based on their likelihood of belonging to a cluster. So the probability distribution can be Gaussian algorithm or binomial algorithm, etc. There are many algorithms used for the distribution based, that is statistical distribution based. It has main advantage of this is that it is flexible and correctness compared to the other algorithms, and it is also it produces results in such a way that shapes can be of any type. The clusters need not be spherical always. And the only thing disadvantage is that it works very well with the synthetic data. That is, synthetic data is the data set that we give. We know how defined is that, how many missing value. We know what all is there and what is not there in the input data. So that is called the synthetic data. When you are not sure what is it, this algorithm does not work well. So and predefined, when most of, because when we know this input very well, information about the input, the most of the data points will undergo the same probability distribution or statistical distribution. So it is completely predefined. So the results also will be proper. If not, if you are not sure of the input data, inputs, columns, or anything, the results may not be proper, or maybe sometimes the results may overfit. Now example of distribution is Gaussian mixture model. We have explained this Gaussian mixture model. It handles overlapping clusters, and it models a covariance structure of the data and provide probabilistic cluster assignments for each data point. Python implementation is from sklearn.mixture import Gaussian mixture. Here we are giving the parameter components is equal to 4, so there are 4 clusters formed here. This is a sample output of GMM model. Now advantage is that it can give a output in various shapes and sizes. It deals with missing and incomplete data, and it can be used for few problems like density estimation. And the new generation data points also will be handled with a predefined set of probability distributions as the original data. And it also provides information about uncertainty of the results. It can be used for semi-supervised learning where the input is not labeled properly. Now, disadvantage is that computational risks and very expensive. It is prone to overfitting because every data point goes and undergoes a probability distribution, and as we said, it will work only well with the synthetic data. That is the input that we give. Maybe if at all the input is completely is having lot of missing values, a lot of input is not unknown, it is not proper with the data types, or so many analytical processes and all is to be done, then this model may not work properly. And the initial parameter, with the initial parameters, it can be sensitive to noises also. Okay. In hierarchical based algorithm, the clusters are formed orderly in a hierarchical base. Either it might be up down approach or bottom up approach. Here they use Ward method to calculate the distance between clusters. So, and they call this representation as dendrogram. There are two types of clustering under hierarchical base, that is agglomerative clustering and divisive clustering. Agglomerative clustering is bottom-up approach that produces a dendrogram, that is small parts of the